The state design pattern is used when a behavior of an entity, an object, might change depending of the state that object is in. So instead of us playing detectives and trying to figure out what's the state of some entity that some object, for example, might have, we can use the state pattern to help us. Easiest example is a multi-stage form that our users might have to populate. Now, most forms have a few different states if you think about it. These states could be empty, like no data. There is a draft, like some data. It could be incomplete. Some required fields are missing. It could be invalid. Some fields are actually invalid. It could be valid, meaning ready to submit, and it could actually be submitted. Now, how do you find what state the form is? Well, obviously, we put a series of if-else statements in a bunch of checks on different properties in multiple places in our application to figure out if we should show a validation div, if we should hide some other part of the application, if we should reset the form, and so on. So each time we need to hide some element on the page related to the form, we need to remember which parameters to check and how to handle them. And if our form structure changes and we add another field, we need to remember to change that particular field in multiple pages in our application, in multiple if-else code. Or we could instead introduce a state to this form, which is a state design pattern. And this is the problem that state design pattern tries to solve. It represents the state of some entity, some object, some process, so that we can react to it. And a bit more. Whenever we are multiple different states in some object, in some application, we could consider this a pattern. Things like a page or news article on a website, it goes through different states like draft, reviewed, private, published, archived, etc. A web application could have an online or offline state down to maintenance and things like that. So a state of a support ticket, which is an example we will actually build in the skill builder module. Or an order in an e-commerce goes through different states like order, handled, pending, packaged, shipped, cancelled, received, whatever. The state patterns allows us to easily handle different states so that if an order is in some specific state, it will actually behave differently without us having to put any if-else when checking if the order could actually be cancelled. Its advantages are flexibility. It's very easy to add new state or update existing one without changing any logic in our application. The clean code is much cleaner and more organized than using a lot of if-else code. And expandability. As application grows, we can just modify states as needed because the code is easy to maintain. Some trade-offs are, again, complexity, as pretty much any design pattern. It is a bit more complex than a simple if-else, which is not always ideal and necessary for simpler applications. There is a lot of code. There is a bit of setup and boiler code that we need to set up for each state, so we need to consider that when using it. If we want to avoid two if-else statements, maybe the state pattern is not ideal for this situation, as we will end up with more code and more complexity to maintain. So like any design pattern, it obviously needs to justify its existence. That is why we are learning them here, to know when and how to use each design pattern, to know its benefits, its trade-offs. And state design pattern should be used when we have different states, more than two ideally, and we need to change the behavior of some components based on the state it is in. Let's look at one real-life problem that we can solve with the state design pattern, and that is the status of one digital order. Here we have a simple order application, the simplest one in the world. Here is actually one order entity, one class, where we are tracking the status of the order. Now we have variables, whether the order is being paid or if it's being shipped, and these variables actually represent the state of the order. For now, everything is set to false when we start this object, and somewhere in our application we are actually trying to ship our order, right? This will actually not work if our application is not being set to paid. So if I would comment this, and if we look in our browser, we get cannot ship, order is still pending, right? So that's one state of the application. If we, however, set this to paid, to to true. Once we process it in the database, it will says that the order is being paid. And then somebody in the admin says, okay, let's ship it now. And we can see that it's being shipped fine. Now, this is all fine and clear and understandable. There are 3 states with the order so far: created, paid, and shipped. And our task now is to add a new state for when the order is being packaged, which is right before the order is shipped. We want to reduce the information gap for our customers and keep them in the loop that we are now actually processing their payment, we are packing it. However, we need to ensure that the order is paid and it is also packaged now so that we can actually ship it. So this ship operation might maybe contact our post office and give back an order number or something like that. Now, how can we do that? How can we create that additional step in this process, the additional state in this process here? The easiest way is to put one if-else around the is paid and maybe add something like is packaged as well. And then we need to set this packaged to false as well. Then we probably need one more if-else here, saying that or else if this is not paid, we need to show some information to the person who is trying to do this in the admin panel. We need to show some confirmation or some error message saying that we actually cannot ship at this stage because the order is not being paid completely. Then we probably need another one for the not packaged, right? Because we need to say that it cannot be marked as shipped because it has not been marked as packaged first. And this will actually work fine. However, we know how we feel about a bunch of if-elses chained one after the other, like in these examples, because maintenance becomes quite difficult and it's very difficult to say which state the order actually is in. In order to understand in which state the order here is, we have to track 2 or maybe 3 properties here, parameters. Is it shipped? Is it packaged? Is it paid? You have to go through each of those to check which one is it. But I hear you say, well, that's very easy. We can just add another field name called state. And we can probably start from draft. And then we can just cycle through these states in this variable. Then we can check and relatively easy see the status. Is it draft, paid, shipped, whatever. And this is actually a very decent solution here. In this case, we have a string. We could have an enum or integer from 1 to 5 or something like that. But we are still depending on some strings here. It would be easy to make a spelling mistake here and maybe change this state to something in between or something that's not accounted for in the code, and weird things will happen. Also, there is no encapsulation of functionality here, so all the order methods behave the same way, whatever the status is. To prevent that, maybe we don't want this shipping order to fire, like in this example, unless all the conditions are right. We still need to keep a lot of if-elses here, maybe giving different notifications or maybe giving different information back to the business logic actually trying to do the shipping. And I will show you why that is important later in this video. But in each method, like ship order and then in the maybe payment order, we still need to put a lot of if-elses, right? Even if we go with the this status field, there is a lot of checked here, right? If it's packaged, then we need to move it to shipped. So if it's shipped, we probably need to move it to paid. If not, we can set cannot. You probably cannot pay if it's not verified that there is enough stock in our inventory. And everything here will actually work fine in the beginning, but after a while, it will quickly become cumbersome to maintain when we add additional state. And it all just becomes a heavy thing to maintain here. So obviously, we're going to talk about how to solve this with a state design pattern. And I have to be honest and clear and frank that this is a bit tricky design pattern to implement if you've never done or never seen it before. So please bear with me and don't get frustrated because it's a lot of code or because it's something completely different or new. That's why I left this design pattern maybe at the end of this course. But it's a very cool design pattern to know and understand, and you are so far on a good track of understanding difficult concepts, so I'll explain this in the next lesson. But try to think on your own, how would you solve this without having if-else statements in our code, purely using maybe other objects? And I hope you will like my solution when we look at it in the next video. Let's look at one theoretical example of how the state pattern helps us manage the article state as it transitions between draft, published and archived states. Now we are already tracking the state with a string in this variable here, article.status, and we've said that it's maybe not the best thing because we still have this series of if-elses here in every method that will react differently based on the state application is or this article is in. So here in the delete article we have archiving if the article is already published, and then we have deleting, actually removing from the database, if the article has only been a draft so far, meaning that it was never published. And this is so far something that we can easily tolerate. However, if we look at the update method, we can see the same mess, the same kind of thing, the same problematic going over. We can just update the article if it's a draft, but we have to make a new version in the database if it's already being published, or in this case we cannot even update the published article. Maybe you have some requirements where you're not allowed to just update some of the articles, right? Or you need to see the history at least. Then we have to make a new version of the article, and there are similar rules for different states, right? Now you can easily see, I hope, how this will grow in complexity with both many if-elses here for many different states, but also where some states would share some functionality, at least some logical functionality here. So maybe an article could not be deleted if it's published, or if it's already deleted, archived, and things like that. And probably this if-else needs to be in several other places in our application as well. And if a new state comes into the application workflow, we have to update each and every of these if-elses, make sure to double check if all works fine, etc., etc. So it's just difficult to work with. So how can the state design pattern actually help us here? Well, what we can do is make a specific handler for every state the article is. A specific object, a specific sub-object, or specific functionality, however you want to call it, that will handle some operation depending on the state an article is currently in. This way, our specific state, in this first case, is the draft state. It will update the article just fine, because we said that the article can be updated when it's in a draft state. It will also remove the article from the database fine, because the draft state allows that by design. We want our drafts to be deleted, right? However, if it's in the publish state, then the update method will not allow us to do that. We have to make a new version. It could even do the making of new version for us here instead of throwing new errors. But also, when we ask to delete the article, it would actually do the archive. It will not allow us to physically delete an article from the database. And if we look at the article itself, we can see that it's actually not handling any of these odd logic itself. It's just calling the different states or the methods depending on the state it is. That way the article does not have to decide each and every time what the logic for doing a specific thing should look like in this case deleting the article. It will just call its state.delete, and the state will do the deleting of the article, if it can do it, if it's in the draft state in this case. But if it's in a published state, then it will only archive it rather than actually physically delete it. Well, I say physically, but you know what I mean, from the database. And this is the essence and the main point of the state design pattern: to allow one specific object, in our case the article, to behave completely differently depending on the current state it is currently in. So if it's in the draft state, it will update the database and it will delete from the database just fine. However, if the state has been changed to something like published state, the article
will actually behave completely differently. So we don't have to think about what the article will do in the database and how will it handle it. We just ask our article to update or to be deleted, and it will do the rest based on the state it is in. It will not allow for updates and it will not allow for removing from the database if it's in a draft. Instead, it will do the archiving. And this way we can avoid a lot, if not all, the if-elses that are impossible to read and understand, and our code will be much cleaner, much easier to maintain and to debug and to actually work with. So let's solve our problem of order, which is in the paid state and needs to be shipped, but also needs to be packaged first. I will just remove this code so that it's a bit easier to follow, and we will go back to the original simpler example. And I'm going to do a lot of changes to make in this lesson, so I urge you to please focus and take your time understanding what I'm trying to achieve here. You might even look at this video a few times if you're missing some parts, and I will try to go several times over the code and change code in more detail so that it's easy to follow. So what I'm going to do here is to introduce a new object, a new state object, which will handle shipping for us. So instead of main object doing the shipping here, the order, this new state, new object will do the shipping for us. And I will show you why, so please bear with me. So first object I'm going to introduce is paid state. Now this paid state here is going to handle the shipping. So it will have the ship order method. And this ship order, if you remember our task, cannot execute once the order is in the paid state, but rather when it's in the package state. So ship order will actually return cannot ship. Order is not packaged, is still in the paid state, right? So we are now working on the paid state. Now in the order object, we are going to remove these flags and we are going to pass in the state of paid state. So we are just going to start from the paid state. Now it is important that we in the paid state pass this order object. So this order object from here is actually going to be passed inside this paid state. And here we are going to accept it in the constructor. So in the constructor, I'm going to give it the order object, and this order will be order. So I'm just going to store it here. And why is that important? Because once we are in the paid state, we can have the method called package. Now, since the order will start from the draft state into the paid, and then into packaged, and then into shipped, now we are on the paid state, we can move the order from paid to the package state. So in this package, I'm actually going to put the console log, just for us easier to see what's going to happen. But then I'm going to say that this order state, now we are working with state, equals new package state. Now we haven't made this package state, but before we do that, I just want to try and ship the order which is in the paid state, so that we can see if this one will work. For this to happen in the ship order, we are going to call this state ship order, right? So we are trying to call the ship order on this state. We don't need this flag here. If we try to ship this order, which is in the paid state, we see that we cannot ship it because order is not being packaged. It is still in the paid state, right? So that means that we need to package it first. Now we need the package state, right? So let's create that one quickly. So I'm going to make one package state. And in the package state, I'm just going to put the method for shipping, just to make this simpler. So let's make one ship order. And we're just gonna console log that it's been shipped successfully from the package state, right? So we are controlling the flow of our object from different states here. Now nothing has changed. So here, before shipping, we should just say order.package. And then in our package method here, we need to actually call our package method from the state that the order is in. I will come back to this, so please follow, and with a bit of luck, everything will work. And we can see that the order has now been packaged from the paid state. So it was in draft or in the paid from our start. Then when it's been packaged, has moved from paid into package state. And then that is this code here. So from paid, it moved to packaged, and then we have shipped it, and now it's in the shipping state. So if we forget to package the order itself will manage its state, or depending on the different state, this function will behave differently. Now watch this. I will just run through the code to see what's happening here. Let's run this one. When the order is in the, so we are starting from paid now. This is now paid state. And we can even see that in the console log that the current starting state is order.state. So we can see that the starting state is paid state, right? From it, if we ship, it cannot ship. Order is not packaged because it's still in the paid state. And what has happened now is that I will just open this file, the same file in two splits here so that we can easily follow what's happening. So this is the exact same file that I'm going to open in parallel here so that we can follow. So now when we create an order in the constructor, it is being set to paid state, right? So this first new makes the state to paid state, which is actually this paid state here, right? So now the order is in the paid state, and that is what we see when we dump this here, that the starting state is order state, right? So that is this one. Starting state is, paid state, right? So starting state is paid state. And when we call this ship order, it will call this ship order here, which will then call this state ship order. And since our application is still in the paid state, it will call this one's shipping order. And that is, if I scroll here gradually, it is this ship order here, right? So by calling this ship order, we are actually ending up in this particular ship order of the paid state, right? Because that's where application is at the moment. And it will say cannot ship, order is not packaged. It is still in the paid state, which is something that's reflected here in our console log, right? It is still in the paid state, so it cannot be shipped from this state. Now, if I am going to pack the application, it will change its state. And we're going to log this one again. So when I run this code now, we can see that it starts from the paid state. Then it gets packaged. So now the state has changed to package state. From there, it can be shipped because it is already packed. Now, how in the world does this work? Well, let's try to see what happens here. Now, when we call the order, it gets into paid state, and that is fine. That's what we have here. This is paid state, right? But then we ask the package on paid state, which is now this one, and that paid state will pack our code, our order, which means that it will now change the state to package state, right? And that is what's being reflected with this console log here. Now the application has changed its state, so this paid state is not valid anymore. This is not relevant anymore. This has been changed now to package state, and now we are looking at this class or this object, which is current state. So that when we say ship order on our order, since the state is now in the package state, it will call this ship order, which will just fine ship the order because it is in the package state, which is something that we can see in our browser. It's shipped successfully from the package state. So you can see how a different state dictates the behavior of an order. If it is in a wrong state, even calling the exact same method like shipping in the package state, in the paid state, it will not work because this shipping on the package state will just say cannot ship. For that to happen, we need to change state. So here state changes to packaged. If we then call ship order, it is not a paid state anymore. Now it's package state, and the ship order now works just fine because this ship order knows that now the state is correct for our order for it to be shipped. And if you remember from our task, we needed to add a new state called packaged before the order is shipped. And we have changed the state not from the controller here, but inside the package method. And that is our little trick. If I go here to the order itself, where in the paid state we have passed the actual order so that the paid state can actually change the order state to some other state, in this case, package state. Now we could have passed the order again here in case the package state needs to change the order state again. And don't worry if this is confusing, just bear with me. We will see how this runs in the end. And when I first saw this working, it took me probably a few hours, maybe days, to truly understand how in the world is this possible and how it works, because at the bottom here it's the same order, right? And suddenly this method is completely different method than if you package the order first. So if it's like this, or if it's like this is not the same method, it's not the same code that's being called. And that is the point of the state pattern, because it can very easily change the behavior of this order based on the state it is, right? If the order is paid and we remove this package, we can see that the order is in paid state, so it will not ship. But if we just say, well, okay, now it's packaged and this packaged is actually paid state, right? It will change to the package state from the paid state. Then if we call the same exact object, ship order, it will work just fine. It will ship this. So it's a completely different method. It can do completely different things. But I think that even though this is a bit confusing and a bit difficult to follow, it's actually very cool. We have one order that is changing first its state on its own, but also it's changing its own behavior of its own methods. And all that without a single if-else in the code. It's not that I don't like if-elses, but sometimes solutions could be a bit simpler or more robust, to put it like that. But look at the usage of this code. This is a very clean and very easy to understand code here, because we know that when the order is in the package state, the ship order will do this functionality. And also when the app or when the order is in the paid state, we can see that calling package will actually change state, right? It will also update something in database. But when we are trying to ship the order from the paid state, we can clearly see that it cannot ship because it's incorrect state at the moment. And this is super clean and super easy to work. You just open file and see immediately that this state has this specific behavior, what it does, how it works. You don't need a cheat sheet with all possible combinations and all possible flags and all possible states. You can just follow along these different states and see how it behaves. So all you have to do now is to chain different states one after the other, like order placed, cancelled, delivered, or packaged before delivered, and things like that. And probably you can see how useful this would be when the order is cancelled. You can just, in a sense, overwrite all methods here and make sure nothing is messed up. So regardless if somebody clicks in the admin for a cancelled order to be shipped or to be packaged or something like that, the order itself has all the mechanisms to prevent that. Now, to be honest, depending on how many states you have, this could actually grow quite a lot. In my opinion and my experience, this works and actually looks much cleaner than having 20 or 50 if-else's in every possible method and in every possible controller. But having that said, please make sure to use this design pattern only when you need it, because you can see how having 10 different objects in different states would actually make this maybe difficult to read. And at one point you might have a documentation and a drawing with all the states that exist and how to use them. And I have personally used this pattern, I think, 20 times in 200 projects that I worked with. And it's great to know when you have a specific use case, but it's also great to know when to actually use it. So make sure to use the skill builder exercise to master this design pattern, because this one specifically requires a bit of training, at least it did for me. Let's look at a few examples of libraries and applications that use state design pattern in real life. The first one I found is this library, egg.js flicking, which is actually a carousel. So it lets people swipe between images and some other page elements. And it supports multiple frameworks. And it also uses the state machine to follow the state of the carousel at any given moment. So here at this state machine file, we can see that this method named fire actually will change the application state between hold and change and release and animation and things like that. So it will actually iterate over them. And right below they have a clever solution so that your application changes into the appropriate state, right? So here it's reacting on finish, but here it's transitioning to a different state. And here when the next state enters, it will receive the previous state actually here. And here we can see all those different states that have different behavior. So if we are into the dragging state, we can see that on change it will move to change position, right? But on release it will do some other logic, and each state has a different functionality depending on the state this carousel is, right? Whereas this dragging state has a completely different on change and on release. This one is probably doing completely different things while you are dragging this, but it also allows you to do some additional things with your application while the user is interacting with this application here. We can see that if panel count is less than 0, it will go to idle, otherwise it will go to animating, and there is probably also a callback. I think I saw it somewhere. I cannot find it, but there is probably a callback that you can have once the application transitions from one state to the other state. Like this holding state, for example, has a completely different on change and on release, and also has on finish, which is quite complex and things like that. The second example that I have is actually the React. You probably used it, but it's React state. Now the React state is probably implemented quite differently than a typical state machine from the regular state. It's just due to the complexity of the React and the granularity that it needs for all use cases. So I don't think that React actually uses something as simple as example that we were discussing here, but it's a very similar concept of stateful behavior. React and other single page applications frameworks heavily rely on management of state as a way to track their changes in the UI. So each change to a value, whether it's a form click or a button click or drop down or maybe a network response, it updates the component's state, and then React automatically re-renders the UI to reflect that change. It reacts. That is how React actually keeps the UI in sync with the underlying data. And it says that you basically need to visualize all the different states of the UI that the user might see, like empty typing, submitting, success, error, etc., so that you can have different states here for the submit button, right? But also here you can see that the state of submit is disabled, and that's based on the if the status is empty or submitting, but maybe if it's an error, it will just not work. So you need to put the correct city here, and that will trigger this state here. And that's how the React controls the state of different UI components, right? So this is not state machine, but it's a stateful approach to UI behavior, and a great example of how thinking in terms of states, different states, can make UI logic more predictable and easier to manage. And this is very similar to what you will do on your own inside the skill builder later. So I encourage you to stick to that lesson. But here we can have it visualized how the state changes, for example, from empty when you start typing into, well, typing state, because we don't want autocomplete to kick in while you are typing. But then maybe between submit you need autocomplete, and then you're moving to submitting. If there is a success on the backend, then the state is success, but then also it can become network error or the error state for this form, depending on the backend response. And as you continue using React, you'll see that state is everywhere because we can never fully predict what the user will do next. So we need to organize the application flow in different states. We can only react to user action based on the current state of the application, right? A final example here I have is this X state application, library, which is actually to helping manage the application state. This design pattern is so much used that there is a specific library designed only for those purposes. There is specific for React, there is specific for Angular and for the Vue and for all other frameworks, major frameworks. But this one can be configured in a few different ways. They have few examples here in this fetch example, where we can see that this sample application actually went from different states like loading, failure, loading, success, and these are the states of the state machine. And another example that I have here is this stopwatch, which I actually never managed to see these the states here as they promise, but you can imagine that there is a different state that this stopwatch is, because now stop is disabled, right? Because the application is not in the running mode. But when you click start, it never shows here, but you can imagine how the state will actually change from being started to stopped to something in between, right? Now, this should give you some inspiration how you can implement this logic into your own app to control different parts of your application based on the current state of your application.
Let's summarize this state pattern. Do you remember what it allows us to do? It separates an object from its state. It also allows an object to change its behavior, well, based on its state, right? And this involves creating state objects for each possible state of an object and then collect specific or group specific behavior inside each appropriate state. So if we make a user object, for example, the login method would throw an error if the user is in the not activate state, or it will actually check against the database if the user is activated and eventually ready to log in. Now, in real-world projects, it's also used for UI, for state of users, the state of orders, different libraries use it to track state of variables, state of page component, articles, texts, and many other things. Now, do you remember some of the advantages that we mentioned? We talked about flexibility, because we can add new state and change existing state without touching the business logic of our entire application. Depending on our implementation, this can be as simple or as complex as we need it. We also talked about scalability. As our application grows and gets more complex, we are prepared to handle any flow or different state that a user might have. Maintainability, our code is much easier to maintain and easier to follow under the condition that the state pattern is carefully and properly implemented. Now, do you remember some of the cons, some of the disadvantages that we had? You can guess the first one, it's the complexity. And yes, I know I said that code is easier to follow, but that doesn't mean it's always simple to actually work with, to code and maintain. If state is complex, we can end up with many files, maybe a pen and paper to note down what is actually happening in our application. The last thing is code overhead. Since we are actually need a class for each of the states, we can end up with many classes, with many files that also follow with some boilerplate code and setup and maintenance and the common functionality and things like that. So like any other thing in programming and in life, we need to understand and weigh in the pros and cons and decide if this is the right tool for the job. What is most important for me is that you now have another tool in your belt.